A revolutionary team has acquired a pre-ancient Egyptian granite vase. The manufacturing process indicated a manufacturer beyond our current understanding of them. Since gaining access to the data, they have dedicated our efforts to enhancing our understanding of this extraordinary object, and they have made significant progress. Although there is still much to uncover, they would like to share what they have learned thus far. The revelations that have emerged from this investigation have surpassed our expectations, revealing the exceptional nature of this object. While they are unable to draw direct conclusions regarding the origin and age of the object, they have acquired substantial knowledge about the capabilities of its creators. Please note that this article is lengthy. If you wish to determine its value before investing your time, you can skip ahead and read the conclusions, which are sure to captivate your attention if it hasn't been already. However, if you have the patience, they recommend going through the content in its presented order, as there is a wealth of information to unpack. Mathematics will be employed to elucidate various points in this article. However, they have made an effort to ensure that the mathematical explanations are easy to follow. A basic understanding of geometry and algebra should suffice for comprehending most of the concepts. While there may be sections with more intricate equations to validate our model, they are not essential for a comprehensive understanding of the article. They have taken care to highlight the main points in a manner that even those uninterested in mathematics can grasp. Therefore, feel free to skip the mathematical sections if they do not resonate with you. In this article, they utilize radians as the unit to describe angles, as it is a universal approach. Radians are based on the fundamental ratio between a circle's radius and circumference, whereas degrees are an arbitrary division of a circle into 360 parts. Degrees lack the foundation of fundamental mathematical ratios or constants, making them less suitable for this analysis. Radians, on the other hand, reveal underlying mathematical relationships more clearly. If you are unfamiliar with radians, they may seem unfamiliar at first. However, fear not. They are actually simpler and more intuitive than degrees. All you need to know is that there are 2 pi radians in a circle and pi radians in a triangle. For instance, a 45 degrees angle is equivalent to pi, 4 radians. Any angle can be expressed as a simple fraction of pi. They firmly believe that our current model provides overwhelming evidence of the presence of sophisticated design principles, intricately interconnected relationships, and design constraints within the object. While they cannot ascertain with certainty whether our description of the design perfectly matches that of the original creators, they are confident that our reverse-engineered model accurately represents the mathematics, interrelationships, and constraints inherent in the original design. Although there is still much to learn about this captivating artifact, the knowledge and data they have acquired thus far enable them to draw some conclusions with confidence. Regarding the possibility of chance occurrence, is it conceivable that an object like this could have been the result of sheer chance? A rare coincidence of random alignment? No. Such a proposal would be purely magical and superstitious thinking. Maintaining absolute precision and consistency by chance alone, across all the interconnected systems present in the object, is simply impossible. Waking up one morning to find an entirely new universe emerging from quantum fluctuations in one's left nostril would be a far more likely event. While it might be possible, through extreme luck, for an object to randomly display the value of pi or phi somewhere, it's crucial to remember that all systems in this object are tightly interrelated. Altering one parameter would disrupt everything else. In this case, at least 15 levels of interrelation exist, all in perfect harmony even at microscopic scales. This object was meticulously and carefully designed by a human being possessing incredible levels of skill, insight, and artistry. There can currently be no doubt about that. Required design capabilities. What kind of system would be necessary to conceptualize the abstract design of the object before its manufacture? Could the object have been designed through analog means, such as a drawing on paper used as a guide during production? Addressing this question satisfactorily requires careful consideration of numerous factors. While a future article will delve into this matter more extensively, they believe it is worth briefly touching upon our initial conclusions here. When examining the scales at which precision was maintained in the object, interesting challenges arise. The smallest identified radii in the object are only around 1 mm, but they scale perfectly, with precision in the micrometers, to even the largest radii, approximately 63 mm, within the object. Attempting to achieve this level of scaling on any analog medium would introduce immediate errors that would accumulate with each radial traversal. Even with our modern, finely tipped drawing tools on the smoothest of paper, errors close to the full radii of some of these circles and features would occur. To account for and control such errors, the designer would need to scale up the blueprint to proportions of several meters or more, raising further questions about how to subsequently transfer it back down to the small dimensions of the actual object. Perhaps the most plausible way to represent this object on an analog medium would be through geometric and mathematical descriptions. This approach is feasible, and one could create sketches along the way to approximate the final design. Our civilization has possessed the necessary mathematical knowledge to do this since around 500 CE. However, faced with the challenge of transferring this design through a manufacturing process to a physical object, they find ourselves back at the starting point. They would then need to produce an analog template capable of guiding or controlling the manufacturing process. While the point I will now make requires formal substantiation, I feel it would be disingenuous not to bring this argument to its logical conclusion and stand by where the evidence and logic led. To the best of our knowledge, no human beings, trained animals, or naturally occurring phenomena, whether modern or ancient, take mathematical formulas and equations as input and produce lathe operating motions as output. For all the knowledge and insights they have amassed over the ages, they know of only one category of things capable of such behavior, what they refer to as a Turing machine. This class of devices can take input, hold state, perform operations on the held states according to predetermined principles, and produce output. Turing machines come in various forms, sizes, and can be constructed mechanically, electronically, pneumatically, or hydraulically. You are likely using one right now to read this article. They commonly refer to these devices as computers. Thus, representing, operating on, or manufacturing the design of this artifact in any plausible way would require access to a Turing machine. Required manufacturing capabilities. When comparing the output of our generative model to the physical object, they can gain rough insights into the fabrication capabilities of the object's creators based solely on observable facts. From this analysis, they can draw the following conclusions. Since there are no known records or ideas about how additive manufacturing with granite could work, they assume a subtractive process such as cutting, carving, grinding, ablating, etc. The creators of the object consistently maintain tolerances of approximately 30 micrometers in the subtractive processes involving granite, with many areas exhibiting tolerances of less than 10 micrometers. Tools used to remove material from the granite blank must have been held with exceptional axial stability to achieve these tolerances. Technologically, this level of precision is only attainable with ultra-smooth and precise rods, bearings, ball screws, and similar mechanisms. Incredibly precise guiding mechanisms must have been employed to control the subtractive process, as the finished object adheres to the abstract design with microscopic precision. This necessitates mechanical technology of ultra-high quality, rivaling or surpassing what they can produce today. No perceivable loss in calibration or positioning is observed across curves of different radii or their positional interrelationships, suggesting that the creators of the object were able to machine it in a single pass or carry out tool changes with minimal loss of positional calibration. The placement of exterior features and the maintenance of precision across the areas between the handles indicate that a simple rotational process would have been insufficient to produce the observed geometry. The simplest manufacturing process they have conceived for the object would require a system with at least 5 degrees of freedom to guide the subtractive tool. Summary of conclusions. Based on our current best understanding of the object, along with knowledge of the fundamental limits of physics and the laws of nature, they must conclude. The object was fabricated using a highly sophisticated subtractive manufacturing system from a solid piece of granite. The manufacturing system would necessitate sophisticated mechanical technology and high-precision components at the very least. The manufacturing system would have required automated control, capable of reading the design as input and producing the necessary motions as output. A Turing machine of considerable sophistication would most likely have been employed to create, operate on, and transfer the design to the manufacturing system. Attributing the production of this artifact to anyone lacking the technological sophistication and capabilities mentioned above is implausible. This raises intriguing questions regarding the object's origin, which they hope to explore in future research. Future research. They hope to scan a number of similar objects, of which thousands exist in museums worldwide, using the same or improved scanning technology, thereby building a body of work focused on analyzing these remarkable artifacts. With the analytical tools and technologies available today, they stand at the dawn of a new era of inquiry into our past and shared heritage. Few endeavors could be more valuable than deepening our understanding of our collective origins as a species and as individuals. Only through open, critical, and honest scientific inquiry, rooted in concrete and verifiable data, can they shed light on the most obscure echoes of our shared past. They must allow the observable facts, the given information, to speak without prior interpretation, even if the conclusions temporarily challenge our previous understanding. In scientific pursuit, all theories are provisional.